Previously, we created transaction objects with the ability to update themselves with new output objects generated from the same sender. We also have a transaction pool that collects these transaction objects. The pool also replaces transactions that come into the pool whose ID matches a currently existing pool, or rather a currently existing transaction within the pool. What's left is to tie these concepts together. Let's capture the update of a transaction and its replacement in the pool within a method for each wallet called createTransaction. So createTransaction will do the job of generating new transactions based on a given recipient address and amount. It will also check if a transaction from this wallet already exists within a given transaction pool. If so, it will replace that with an updated transaction. So let's define a new method within the wallet class called createTransaction. It will have three parameters: a recipient to designate the transaction for, an amount to send to that recipient, and then an incoming transaction pool object, so that way we can check if transactions already exist within that pool. First up, we don't want to create the transaction if the incoming transaction is too high. So let's check if the amount currently exceeds the balance of the wallet. If so, we'll log an error and return out of the function. So if the amount is greater than this.balance, well, we know that they shouldn't use the transaction, or rather create the transaction. We'll console.log that the amount, and then we'll interpolate in the amount variable. We'll call the ES6 template string with backticks, and then $ pair of curly braces for the amount, and then this amount exceeds the current balance. And then we'll also interpolate in this.balance, so that way they can see what their balance is that they're currently exceeding with the transaction. And then we don't want to continue with the rest of the function in this error case, so we'll have a return statement to escape out of the function. All right. The goal of this createTransaction method is to replace a transaction in the pool by the sender with an updated one if it already exists, or to create a fresh new transaction and add it to the pool. The first step in that process is checking if a transaction attributed to the sender already exists in the pool. To check if a transaction by this wallet exists, we can use the find function on the pool's transaction array to locate an object whose input address matches this wallet's public key. That logic really belongs in the transaction pool though, so let's assume that the transaction pool has a function called existingTransaction, which returns a transaction based on a given public key address if it exists in the pool. So we'll make a transaction local variable that is set to calling that existing transaction function within the transaction pool. And now we're assuming that this transaction pool has this existing transaction function that returns to us whether or not a transaction pool exists based on giving a public key address. In just a moment, we'll write the actual function in the transaction pool that we're now depending on called existingTransaction. This transaction variable will either be the existing transaction object or it will be undefined. So we'll execute conditional logic based off of that by having an if statement around the transaction. So if, else, and then we'll have empty bodies that will fill right now. If the transaction does exist, well, we want to update the transaction with the given recipient and the amount. So we'll use the update method on the transaction to update it if it already exists. The first parameter is the wallet to generate the transaction, which in this case is the local wallet instance. So we'll pass in a reference to this very wallet instance by using the this keyword. The second parameter is the recipient to update the transaction with, and then finally the amount to generate the transaction for. And now we get to the else statement. If the transaction doesn't exist, well, we want to create a new one. So we'll set the transaction variable to calling transaction.new, and then we'll pass in again the local this variable for the wallet and the recipient and the amount as per the parameters for the transaction.new transaction function. And then with this created transaction, we're going to add it to the pool with transaction.pool.update or add transaction, and then passing in that transaction variable. Perfect. That about wraps it up. Finally, we want to return the transaction at the end of the createTransaction function. Now, notice that the transaction is now depending on the existence of the transaction class in this file. So let's make a transaction constant that is set to the result of requiring the local transaction class that we have. Okay, great. So the function either replaces existing transactions by this wallet, or it adds a new transaction to the pool. The function does rely on this existing transaction function that we assumed existed in the transaction pool class. So let's add that in the transaction pool.js file. We're going to add a new function called existing transaction. We pass in the public key of the wallet to this function, so let's assume that we have a parameter called address. The function will return a transaction from the pool that was created at this address. So we're going to return this.transactions.find. We're going to look through each transaction object one at a time with a t variable, and then we'll look for the transaction object represented by t whose input.address is equal to the passed address to the function. So we're looking through each transaction object one at a time represented by t, looking at its input address variable, and then checking if it matches the given address variable to the actual function. And then if it doesn't find an object, this will return undefined. Excellent. That covers the entire create transaction and existing transaction flow for creating transactions with the actual wallet. Since this is new untested functionality, let's cover these methods in our tests to make sure that they function in the way that we expect next.